So this is the second lesson, testing for symmetry. So we've heard of symmetry before with different graphs. Hopefully a couple graphs come to mind, like quadratic functions or absolute value functions. So we're going to be focusing on symmetry of graphs and equations. So symmetry of graphs and equations. So benefits to symmetry and testing for symmetry are it helps us understand the equation better. Easier to plot, and it can be easier to solve. Alright, so there are three different kinds of symmetry. The first one we're going to talk about is when something is symmetric about the y-axis. So symmetry, symmetric about the y-axis. Okay. So an example of that, let's make a little quick graph. And I'm going to go up to 4. Let's make a little parent of a quadratic. Okay. So quadratic, oh, I didn't actually finish making my graph. Okay. So quadratic parent is 0, 0, right? 0 squared, 1 squared, so 1, 1, 2, 4. Negative 1, 1, negative 2, 4. And please make this a nice curve. So it looks like a parabola. Ooh, that was not bad at all. Okay. So when something is symmetric about the y-axis, then for every point let's call it x, y. The point negative x, y is also on the graph. And here's a perfect example, right? So at negative 1, 1, so that's our xy. The point positive 1, 1 exists. So if xy is negative 1, then this is going to be positive. So this checks out. So it's really easy to tell on a graph, right? You have your axis of symmetry, which is the y-axis, hence symmetric about the y-axis. But there's an algebraic test, because we won't always want you to graph it, we want you to prove it. And the algebraic test is actually quite straightforward. All you're going to do is replace x in your equation. So if you have an original equation, you're like, hey, is this symmetric? You're going to take your x value and you're going to replace it with negative x. And you're going to simplify. Then, after you simplify, you're going to see if it produces an equivalent equation. An equivalent equation. If it does, it's symmetric with the y-axis. Cool. Alright, so we'll practice this in class. Moving on, symmetry about the x-axis. It's not the color I want. Symmetry, symmetric. About the x-axis. So that means that the line of symmetry is the x-axis. Let's make a little sketch here, kind of like above. I'm going to go up to 3 this time. And down to -3, and then up to +3 as well. Okay. Alright, so symmetry about the x-axis will look something like this. I'm going to make like a rotated absolute value function. So here is a graph of an equation. And as you can see, it's symmetric about the x-axis. So what that means, kind of like above, is for every point x, y, for every point x, comma, y, the point x, negative y is also on the graph. So again, it's very easy to tell when you have a graph, but we want you to be able to test algebraically. So it's kind of similar to the last one, but instead of replacing x, you're going to replace y. So we're going to replace y with negative y and simplify. And we're going to see if it produces an equivalent equation. And if it does, it is symmetric about the x-axis. Alright, one more kind of example or symmetry is symmetric about the origin. Okay, so going to do a slightly less accurate graph for this one. And you learned this back in Algebra 2. The graph I'm about to draw that's symmetric about the origin. We actually already talked about it the other day. Anyways, okay, so graph that looks like this. So I just graphed y equals 1 over x. Okay, so if it's symmetric about the origin, then for every point x comma y, the point negative x negative y is also on the graph. So again, easy to tell when you're looking at the graph, but we want you to do an algebraic test. And to do that, I'm sure you can guess what I'm about to write. You're going to replace, these colors look very similar, replace x with negative x, and this is where it's different, because before there was only one value that was the opposite, and now it's both, so you're going to replace x with negative x and y with negative y. And simplify. See if it produces an equivalent equation. So if it does, then it's symmetric by the origin. So basically what we'll be doing is I'm going to give you an equation and I'm going to say like test for symmetry. And you're going to have to test, is it symmetric about the origin, is it symmetric about the y-axis, and is it symmetric about the x-axis. Obviously if one works, then you're done. But if none of them work, then there's just no symmetry, and that is a thing. It's possible for graphs to just not be symmetric at all. But you will have to test for these three. We want to see your algebra, and like I said, we're going to practice this in class. So that is it for today.